Okay, so now we know how we can set up event listeners. Let's now dive into this state concept. And to get started, I simply want to output the text that's input into this text area in a new paragraph below this input in the end. We'll soon also make sure that it ends up in the post component, but for the moment, let's just output it there. To achieve this, we need to store the value somewhere and then reference that somewhere down there. And the first thing you might think about could be a variable. We could add a variable entered body, which maybe is an empty string initially. And then here, instead of console logging the entered value, we could store it as a value in entered body, like this. So we update the variable whenever this function is executed, which happens on every keystroke, as we saw. And then we could use this entered body variable down there in this paragraph. So here we can use our single curly braces and output entered body. So this variable is updated here and is then output down there. Should work, right? Well, if you save that and you type something here, nothing happens. It should be output down there because that's where I added the paragraph. And indeed, if you inspect this here, you will see that below this text area here is an empty paragraph, but it is indeed that, empty. What I type here is not being output in that paragraph. Now, why is that the case? Well, because there is something very important to understand. React executes your component functions like newPost. And it then takes the JSX code returned by those functions, so the current snapshot of the HTML content that should be output on the screen, and it does render it to the screen. But if thereafter, in your component function, you change some variable value that's being used in your JSX code, that won't be picked up by React because this JSX code is only taken once as a snapshot when this component function is executed for the first time. Indeed, if that component function would be executed by React again, it would also consider any updates to that snapshot and update the rendered user interface. But React does, by default, not randomly execute newPost again. And it does not execute newPost or any other component function again just because you changed some variable or just because you have some event listener in there. This is ignored by React. Of course, it adds the event listener and this function executes, but it does not care about whether this would theoretically change your JSX code. Instead, you have to basically create this variable in a special way using a special React feature to let React know about any changes that should cause a UI update. And for that you have to import something from React, so from the React library, not from React DOM, but from just React. And that something is a function called useState. Now this is a so-called React hook. React has multiple built-in functions that all start with use, as you can see here with my auto-completion. And these functions, whilst technically being standard JavaScript functions, are called React hooks. So functions in React that start with use are considered React hooks. The special thing about these hook functions is that you must execute them inside of component functions. You can't execute them in regular JavaScript functions. You can, but you'll get a warning or an error. But you must execute them in React component functions instead. And then those hook functions typically change something about that component or regarding how React behaves with that component. In case of useState, when you execute that inside of a component function, you register a new state slice, as you could say, a new state value that belongs to this component. And a state value can be anything. It can be an object, a number, an array, a string, whatever you want. Here, if we want to store the entered text, we could register a string as a state slice for this component. You set a default value for that state variable, if you want to call it like this, by passing your initial value as an argument to useState. For example, an empty string, just as I did it down there. But again, that could be anything. It can be undefined, it can be a number, it could be an object, but here it's a string. useState then returns something. It returns an array, and I'll store that array in a constant. State data is a name we could use here. Now this state data array has always exactly 2 elements, never more, never less. And the first element of state data is always the current state value, so initially that empty string. But that value can change, as you will soon see. Because that second element in that state data array is a state updating function, a function which you can execute to assign a new value to your state. Because that state value is stored somewhere in memory by React. You set an initial value, and you can then call this function, which is returned by useState, as a second element in this state data array to update that value. Now the special thing about that is that if you call that state updating function, you don't just store a new value somewhere in memory, but React will also re-execute that function in which this state was registered. So it will call this component function again, just as it did initially when it rendered that component for the first time. And since it calls that component function again, you get the current state value, so the value which you just set with help of that state updating function as the first element here. And you get the latest JSX snapshot, and if that deviates from the previously rendered JSX snapshot, React will update the parts in the UI that need updating. And that's, by the way, also important. React will basically make a comparison between the different snapshots behind the scenes and only update the parts in the UI that must be updated so that you don't unnecessarily update the DOM, which is quite performance intensive. So that's what you get back here. Now it's quite common to use array destructuring here, which is a default modern JavaScript feature to store the current value in a constant and the updating function. And typically you should pick names here that describe your state, like for example the entered body, and then the updating function could be called setEnteredBody. It's kind of a convention to name this state updating function set, and then you basically repeat your state name, just formatted as camel case. Now I'll remove that variable here, because we have a name clash otherwise. And with that we registered this state. Now to update that state, you don't try to assign a new value. That's why I also used a const here for these 2 values. Because instead you have to call this state updating function, setEnteredBody, like this, and pass your new value as a value for this argument to setEnteredBody. Then behind the scenes, the new state value is stored, and this component function is executed again, and enteredBody will then hold that new value. That's why it may be a constant, because it's always a brand new constant, because it's always a brand new function execution in the end, when you update the state. So now we can use this enteredBody state here, in this paragraph, to output the new state value. But this time, because we're using this state feature provided by React with help of the useState hook, this will all work. And if I now save everything again, you will see that as I type something here, it updates down there below the text input. So this works now. And with every keystroke, this gets updated, as you can see. Now that's React's state feature in action.